So for the next, we have Fu Xiyang. Okay, yes, one speaker or a few others as well. Okay, together with Tong, Chang and Zhao as well from DSTA. Another very interesting topic, green technologies for defense and security vessels. Thanks.
My colleague Chang over here will be sharing about this topic on green technologies for defense and security vessels. So allow me to give a brief introduction of where we are from. DSTA is a statutory board under the Singapore Ministry of Defense, and our mission is to harness science and technology for the defense and national security of Singapore. So these are the contents of our presentation. So in the maritime defense technology community, we recognize the importance of green shipping to a sustainable maritime environment. While the defense sector is generally exempt from regulatory requirements, our community nevertheless do voluntarily participate in such efforts to achieve a sustainable maritime environment in line with the Singapore government's green plan, as previous speakers have outlined earlier. So our presentation shall share a little bit about the approach and challenges we face in applying green technologies to defense and security vessels. So this slide outlines our approach to applying green technologies. Firstly, the application of green technologies must not affect the operational capability or safety of the vessel. This is a challenge because the design intent of a defense vessel, particularly in the design of the topside layout, is optimized to the operation and safety of the combat systems and sensors on board the vessels. So with this consideration in mind, systems or technologies that are installed on the top side and could potentially affect the safety and operation of the combat systems, such as most wind assist propulsion systems, unfortunately cannot be considered. Secondly, the technologies considered should be sufficiently mature for implementation. This is because of the mission criticality of the vessel. So as an example, hybrid propulsion is a mature technology that is commonly used in commercial vessels, and is something that we are looking at implementing on the defense sector. Thirdly, the technologies applied shall preferably provide both environmental as well as operational benefits. As an example, we are interested in fuel efficiency enhancements, such as reduction in hull resistance, because these also bring a benefit in terms of operational endurance. However, implementing green technologies on defense vessels is not without its challenges. The first challenge is the diversified operational profile that a defense vessel must meet. So in a given sailing, the vessel could be required to sprint, to cruise, and to loiter at various speeds for various periods of time. This makes it a challenge to design because there is not a single constant operating point that we can optimize the vessel for. Secondly, defense vessels are typically constrained in size because of the need to be fast and maneuverable, and the space that is left remaining is typically optimized for the operation of the combat systems. This then makes it a challenge to find sufficient weight and space budget in the ship design to actually fit these additional technologies. And thirdly, defense vessels have stringent requirements for survivability and redundancy. Typically, they are required to be able to maintain propulsion in the event of a single compartment flooding scenario, and they are also required to maintain at least 50% of propulsion and steering in the event of a single failure of equipment. So any green technologies that are applied shall, at the very least, not affect the survivability and redundancy of the vessel. With that, let me now invite my colleague Chang to share a little bit more about what we have done.
Hi, thanks, Taeyang. So with some of the challenges mentioned earlier in mind, there are still some applicable technologies that can be implemented for defense vessels. So we have actually broadly categorized them into three general areas, mainly under more fuel-efficient implementations, more environmental friendly technologies, as well as systems that we have lowered emissions. So looking at the column on the implemented tech, most of these are actually mature technologies that are actually implemented or viable to existing commercial or even other military vessels. So this includes a drag reduction features for wave cutting hull forms or actually bulbous bow designs to lower the resistance of the ship at its operating profile. So similarly, we also have adopted fleet-wide use of fuels with a low sulfur contents or for reduced emissions across the fleets. And also you have to constitute the usage of such applicable engines that actually accept similar types of these low sulfur fuels. So actually, with some of these technologies already been implemented on our existing fleets, we also have started to go into other solutions to further reduce our fuel usage. So we have started to actually do various collaborations with other companies as well as government agencies to actually adopt certain new types of propulsion, such as the hybrid propulsions, as well as exploring the use of various grades of biofuels as a means of alternate fuels for our existing as well as our new vessels. So as we continue to actually push the boundaries for our new builds, we are also looking at exploring various monitoring systems as well as for machinery performance, as well as corrosion monitoring systems. So all these we actually look up even up to the design stage to actually perform some of these measurement tools to actually analyze and also to ensure that the vessels continue to operate in the most fuel efficient manner. So this overall this push towards a more efficient design will help to lower the fuel consumption, but also help to, more importantly, to actually reduce the operating costs throughout the life cycle of the ship. So actually such implementation does pose various challenges, and we actually take reference to a lot on what IMO has actually set up in various sea and air pollution, as well as the CO2 target emissions from currently all the way to 2050. So although government vessels do not have a mandatory requirement to adhere to the rules stated from IMO, we are still referencing these figures as target goals to meet IMO requirements accordingly. So as you can see, the 2030 and 2050 goals are something that we still keep in mind where we actually apply applicable technologies in our new builds. So with this in mind, we have actually established a target roadmap to actually work towards meeting these requirements. So through the use of certain established framework, we will continue to work with commercial industries as well as partners to explore applicable technologies to suit our operating profiles. So in addition, as mentioned earlier, we are also doing various pilot studies and proof of concept trials on various types of technologies and new builds. And with every successful pilot trials, we will actually progressively adopt on our vessels to expand our capability, as well as greater flexibility to adopt various types of green technologies. So currently, there's actually an ongoing collaboration with MPA to actually adopt a green ship concept on one of our newly delivered petrocraft and hunts for the MPA. So this implementation actually helps to push the boundary on new propulsion design, as well as adoption for a more fuel efficient and environmental friendly craft. So actually this slide here shows the MPA green ship that was recently acquired and delivered to MPA and will actually be commissioned in this coming week. So actually to briefly run through on some of the overall design of the craft, there are various green tech that has been implemented in the craft to actually help in this reduction in fuel consumption. So this collaboration actually entails various mature and new technologies that has been implemented on the craft. For mature tech, we actually added solar panels and LED lightings that help to reduce the energy usage across the ships. So actually, although the small bridge top space may not contribute much to a significant amount of clean energy, this implementation on unused spaces on the craft still helps to generate lightings on accommodation compartments for short periods of time. So similarly, the team also adopted various optimized hull designs to reduce the frictional resistance on the craft, as well as propeller tunnel designs for better hull efficiencies. So other mature tech include the use of reflective or low solar absorption paint, which helps to reduce heat absorption, and therefore actually lower the energy usage for your AHU to actually cool down your compartments. We also actually adopted various suitable engines that allows the craft to run on low sulfur fuels and as well as biofuels. So one interesting aspect for this collaboration study is actually the implementation of the adoption of hybrid diesel-electric propulsion, which enables the craft to actually run fully on lithium-ion batteries. So this actually complements MPA's operating profile, as it typically operates on a loiter, petrol, and sprint profile, where running on batteries at low speed and traveling on both engines in top speed will actually suit such a design philosophy. So actually such a design allows the craft to reduce the fuel consumption when operating at certain low speed profiles, which will be running fully on batteries. So actually, as we continue to develop new system and capabilities for defense vessels, we'll continue to explore some of these new technologies that could be practical for certain operations. So actually, with that, we'll come to the end of our presentation. Thank you.
Thank you. Questions? Questions for the two presenters? It's very nice to know that for defense vessels, actually, green technologies are also implemented. It's very interesting. Any question? All right, we have a question.
Thank you very much. Really very inspired to, despite you not obliged to follow those IMO requirements, you all make an effort on that. I said my question is, beside the vessel, how about the port, the base? There are two big bases. And any particular plan or any particular measure that you implemented or plan for it with something similar? What is commercial or so-called MPA aspect of the green?
Yes, in fact, you're right that buildings in general, bases, also make a big impact on energy usage. So what we have done with from a base infrastructure perspective is that actually it's a pretty similar approach to what we're doing with the ships. We are trying to reduce the energy consumption through the use of, in some instances, natural lighting for some of our hangars and boat sheds, solar panels for the use of to produce electrical power for the base. And in fact, in certain parts of the base, the amount of solar energy we can generate is actually greater than the actual consumption required. So it's actually a net energy positive building. There are also some means of recycling of fresh water for the purpose of some of our maintenance facilities. That is to help our the use of our water consumption. So these are some of the areas that, in addition to what we're doing with the ships, is also what our colleagues in the building and infrastructure community are doing to contribute to the Singapore's green plan.
Thank you.
Thank you.
Thank you. Thank you for the question and also the very informative answer. Okay, so I think that will be all. Thank you so much. Thanks to two presenters from DSTA.